is a very advanced topics related to multimedia and the World Wide Web. More precisely, this topic is related to how to deliver multimedia, live multimedia through World Wide Web. This topic is more closely related to the BIT students who have opted for the multimedia streams, but since it is an emerging topic, it could be interesting for both multimedia streams as well as computing streams also. Little bit fundamental concept of multimedia as well as computer network is essential to understand the topic. That is why I will give you some basic background before we move to the topic for discussions. You know that basically the two common buzzwords in the computer industry today is the multimedia and the World Wide Web. You know, the World Wide Web is one of the features of the internet. Like internet has got many features, and World Wide Web is one of the features now. Now internet became very much popular because of the World Wide Web. Worldwide and the earlier version of the internet or the World Wide Web didn't support the multimedia. In fact, the original document when the project was started was clearly written that the project is not aiming for doing any fancy research in the multimedia. So this is what about the World Wide Web. Now coming to the multimedia, there are number of definitions have been given for the multimedia, but one of the most common definition which we understand about the multimedia, of course, that is also not complete, and that is that use of many media for presentation or in the presentations. For example, I can use audio, I can use a video, I can use a graphics, I can use some other type of media for presenting our document. For example, one can give now, for example, one can say that whether the broadcast through TV is also a multimedia, because there you have a audio, you have a video, you have animations, but of course that is not multimedia because there is no interactivity in it. So the most important component in the multimedia is what we call the interactivity must be there. The another important issue which you have to understand, because most of the computing students are attending, they might be watching this program, that certain standards have been given for each of those components, each of those media. For example, there is a standard for text, a standard for video, the standard for the audio, the standard for the graphics, there is standard for other type of, like there is compression standards which is used for the video delivery, that you have to understand. Now let's come back to the main topic now. So basically what we are talking about is that while video streaming is a concept which is used, and more precise definition will be coming up, that when we are delivering the multimedia, live multimedia, if we are going for that now many issues has to be resolved when I want to have a live video presentations through World Wide Web now. But let's try to understand now what is the video streaming. Let's have some one or two definitions, and then we'll talk about the basic issues one has to resolve if one wants to support video streaming. Now one has to understand it's very similar to what we are talking about the broadcasting. Now, like for example, we have a audio broadcast, we have a TV broadcast, and now we are talking about the video streaming now. So the concept, to start our discussion, one has to think that video streaming is similar to the what we call them broadcasting. But the only difference between video streaming and the normal broadcast is that here the broadcast is taking place through the World Wide Web. Now let's start with some of the discussions which we have. Sorry, the streaming video followed with TV, the television, from the mid-1930 onwards now. Most people would prefer to this is the broadcasting. So video streaming is just like a broadcasting, which we understand very well now. What exactly we mean by video streaming is that a continuous stream of informations is transmitted, and the receivers, so there is a transmitter and there is a receiver now. Similarly, you have in broadcasting also there is a transmitter and there is a receiver. For example, your television set works as a receiver, your computer is working as a receiver now. So a continuous stream of information is transmitted, and receivers are able to tune in and receive the information in real time. What we are talking about is right now, again, let me give you some input to understand this topic, that now the trend is changing now, but if I want to see certain live demonstration through World Wide Web, it is not possible. Not because that your internet is, because first that you require a heavy bandwidth. So what they do is that you have to store all those videos or all those information, then you can play them. Right now what we are talking then, that I can see some live game going on, or some live lecture going on, or live discussion chat session is going on, and I can see them in real time without storing those audio video files in the computers now. So that is called video streaming. It's live demonstrations or live discussions without storing those files in the computers. Now, so this is basically many issues are related with if we want to solve or address the video streaming problems. And what are important was that you must understand that here the internet delivery model is the internet. When we say normal broadcasting, the delivery model is the TV or let's say radio now. But here the internet is the basic delivery model now. All the information are being transmitted to the internet. But when the internet was designed, it was not designed for the real-time traffic. It was entirely used for different type of work altogether now. So that is one problem which we have to understand now. The second one, you must understand that the internet has its own problem, because internet is what we call them a shared medium, right? Many users are using this device at the model at the same time, and uses a best effort delivery mechanism. It's not basically what we are talking about here is like this now. When you talk to someone through telephone, it is basically you are talking in real time. You are talking and somebody is receiving and you are getting the response. But when I am transmitting the data through the internet, it is not basically what we call them in real time. It's basically what we call them the best effort delivery mechanism. Now, if dependent upon the time available or path available, your packet will be transmitted. That you must understand that when I am trying to transmit data through the internet, the basic mechanism is that information does not go in one chunk. It is basically broken into number of packets and stored at various on the way at different routers, and depending upon the path available at the next route, data will be transmitted. So what we call the best effort delivery mechanism, because the data the source and the sink is not directly connected. It's connected through number of intermediate nodes and so on. But if you talk to the telephone, you are directly talking to in the real time, but it's not happening with the internet. Because so the real problem when I'm talking about broadcasting of a video or audio or what we call the multimedia in real time, that the basic delivery mechanism, that is the internet, was not designed for that purpose. So all the protocol like TCP/IP protocol is the basic standard protocol for carrying the message, was not meant for this type of work. Of course, lots of research is taking place, lots of development is taking place to support the multimedia through the TCP/IP, but today we are talking about voice over IP and so on. But actual IP design didn't incorporate this feature. They were basically meant only for the textual data transmissions and so on. So this is the so the point which I was trying to explain to you is that in the video streaming and the internet, because that is model which we have, there is no dedicated path between the source and the destinations. What IP does is that IP breaks content into several packets, self-content packets I will call them, and these packets are routed independently. So depending upon the route availability, one packet can follow one route, another packet can follow the another route, and so on. But not so. So if I am sending a one file, I can have a number of packets, and each packets can, so IP routes all the packets depending upon different routes and so on. Not necessarily they will follow the same route now. That is the one point which you have to understand. So the first we have to understand that what internet supports, and if I am trying to transmit multimedia, whether internet is ready to do it or not. So first we have to handle this protocol like TCP/IP protocol has to be tuned for the video streaming. The many other problems are related when we are talking about video streaming through the World Wide Web, and some problems are what we call them limited bandwidth. That is the basic problem now, because earlier very few organizations are lucky enough to have can support multimedia delivery on the net, because you require at least 2 Mbps type of lease line service, and then only you can have live presentations. But very few organizations are having of that. So the bandwidth is very much limited now. The latency is another problem, noise is another problem, packet loss and so on. The retransmissions and out of order packet, that basically what you have in the TCP/IP, that that is the problem, two basic problem, that the packet can be lost. For example, if the packet is being sent, through particular route, if the route is highly congested, then packet might be lost. Or let's say if the highly congested, or let's say the router is not able to deliver them because of the heavy load on another side. So again, if the acknowledgement does not come on the in appropriate time, then TCP/IP understand that packet has been lost. This way the TCP/IP works. So basically TCP/IP is a connection oriented protocol. Now each packet you send, you must get acknowledgement, and they moment, and each time they send the packet, there is a timer. So there is a timeout value. Now within this timeout value, the packet the acceptance of the packet must be, or acknowledgement of the packet must reach this one. If it does not come because of the congestions or because of the heavy traffic going on, or there is a delay another part, or even if the acknowledgement has been sent but it didn't reach, then the TCP/IP understand that the packet has been lost, and the packet has to be retransmitted now. So that is the basic issues which we have. Sometimes what happens that the packets, suppose I have sent 20 packets and all follow the different routes. Some packet reached earlier, some packet will reach little bit later on. This can work with the normal way, I mean, which I have a numeric or data type of packets, but when it comprises of the multimedia packets, the out of order is not permissible. All the packet must reach in the same sequence as it was delivered, otherwise semantics of the picture or semantics of the information will be lost. So TCP/IP originally was not designed to handle this type of situation. So if somebody wants to transmit multimedia, live multimedia, again all these problems related to the internet has to be resolved. Now noise is another problem, and so on. Now that cannot be supported through this one, because sometimes you see if there is noise, you are not able to hear what is going on. That is very much important now. The another important thing which you have to understand in context of the multimedia delivery through World Wide Web is basically when we are trying to test data. See, basically two things are very much important now. We are dealing with that if the one is time critical applications. That is very much important when we are talking about this one, and another is basically the accuracy of the data. When I use sending in normal packets, the accuracy is much more important, because the loss of one bit will corrupt everything. But what we are talking about in the audio and video transmission is the time is very much important now. If there is delay in the packet, then everything will be lost. Then nothing will be able to be understood by the another side. So the time critical time, real time is more important here than the accuracy of the other other informations now. So what exactly we are talking about is that the video streaming is basically time critical applications, which is sensitive to the variation in the delay. That is normal for a shared access network. So if there is a delay, there is no problem in the normal, shared access network like the internet. Not only does the amount of bandwidth that you have access to, that is to matter, but also the consistency or the quality of this bandwidth. So what we are talking about, that not necessarily that you must have a 2 Mbps that is sufficient enough to carry the video streaming, but also the quality of this data, is quality of the bandwidth, that is also important. Sometimes you have a 2 Mbps, but most of the time you don't get 2 Mbps because of the noise and so on. So again, that is the problem now. So these are the issues which you have to be concerned when we are talking about video streaming now. The another important thing what we are doing today is that that earlier, as I just pointed out now, that if I am talking about real time video delivery, earlier it was not possible. What they used to do is, what you had to do is that you had to store them temporarily into your buffer, and then only you can play them. But when we are talking about video streaming, what exactly mean that without storing those files, you can play around. So all internet streaming technologies, we'll talk about this technology little bit later on, get around this by buffering a certain amount of content. They do, but not all. So they still store certain amount of informations then before actually streaming to play. millisecond worth of content can be buffered. So basically here what we are talking about is that today lots of technology are coming, and this technology is called video streaming technology. They also allow you to store some parts of the content before you actually play, but earlier it was not possible. You have to store the entire content, then only you could have played. But now because of video streaming technology, they allow you to have a real time and hardly you have to store anything. You can this is some of the, we'll just talk about what they do now. Is the, so today's technology is little bit improvement because they allow you not to store the whole file, but rather you have to store them very little file. I mean, the most important thing about the technology is that the initial buffering, that the stream broadcast will start to play at the same time as more content is being downloaded. So basically what we have already explained about this one now, that today the technology gives you that without storing the entire content of file, you can play with the file and so on. Now what are those technology? Now let's talk about this few technology. Let's talk about 2 or 3 important technology which has emerged in the video streaming. One is what we call them the 3 open standards are there. One is called, and all are basically by what we call them MPEG. So here the Motion Picture Experts Group. MPEG has 3 open standards that can be used for the streaming. So we'll talk about those technology which has emerged which is used quite widely in the video streaming technology. One is what we call them MPEG 1. The MPEG 1, that you know that we have discussed in the multimedia context, it was originally developed for VHS quality video on the CD-ROM in 1988 and had its own optimal bit rate at about 1.5 Mbps for quarter screen TV, and that is basically resolution at 30 frames per second. MPEG 1 is mainly considered as a storage format. However, it does offer excellent streaming quality for the bit rate it supports now. So the one of the technology which is quite standard, which is used not only for the multimedia delivery through the World Wide Web, but otherwise, that is MPEG 1. And more details we have given you in the literatures. Will not concentrate much on the MPEG 1. Let's talk about another one that was what we call the MPEG 2. That is another second technology now. That was basically designed in 1996, and it was designed for the digital TV broadcast and is best known as DVD encoding. Its target bit rate is a little bit higher than what we had in MPEG 1, but we talk about 9 MB per second. But it can be used in STD for resolution up to this one. So these are the few things, informations which we have. Now the most important information which we have to talk about in terms of MPEG 2 in context of multimedia streaming, that as an internet streaming technology, it is probably not useful as it uses bit rates higher than those to which almost everyone has access. Basically, because you see here they use very high bit rate, that is why we don't use them quite often into the streaming technology. So this is another, but still being used, they might be used in the future. The another is what we call the MPEG 4. So the 3 technology we are introducing you: MPEG 1, MPEG 2 and MPEG 4. This is a recent one which was what we call them 1999, and a new standard specifically developed to address web and mobile delivery now. So this is, I think, the MPEG 4 is going to be standardized now. Its optimal rate is between 385 to 768 kilobit per second. There is still active work continuing in this standard, but number of groups are putting some heavy research and development efforts behind the making MPEG 4. So lots of research is going on. And lots of other technology, these are still a standard, and many other vendors are coming and joining together to support the MPEG 4, because this is used for the mobile delivery of the multimedia and so on. So this is, I hope that this is going to be a standardized technology for the multimedia delivery now. The another one, what we call them, again is emerging but not standardized fully, it's called MPEG 7 again, and what they call them, what we call the multimedia content description content, is scheduled for release in July 2001. All MPEG 1, MPEG 2, MPEG 4 all released, and MPEG 7 is coming sometimes in July 2001, and work has already started on MPEG 21 multimedia framework. So basically 3 standards are emerging today for the multimedia delivery through the World Wide Web. One is called MPEG 4, MPEG 7 and MPEG 21. These are three standards. In fact, you can search more materials on these three standards, see the speed rate and compression ratio and so on. So these are three we are talking about in terms of the video streaming now. Apart from all these things, apart from the open standard, which we call them, because they are not coming from proprietary vendors, they are coming by open standards. Like for example, what we can say that the web is the open standard, is not coming from a particular product. Like Unix is coming from particular vendors, or Microsoft product is coming from particular vendor. But all the MPEG which we listed are the open standards now. But there are some other standards coming from the proprietary vendors. So let's talk about what are those standards are now. These three standards are there now, and you please, after understanding, you please find some literature on these few standards now. So what we discussed now, you don't consider on MPEG 1 and MPEG 2, better consider on MPEG 4, MPEG 7 and MPEG 21, and finally you also can consider some of the proprietary, and these are the Real Media, QuickTime and Windows. So basically what we have is now is that Windows, coming from the Microsoft, the QuickTime is coming from the Apple. These two are quite known, and all three have specific advantages which have allowed them to gain ground in the market, mainly because they are free and support the real-time streaming protocol. The protocol that again we have not talked much about this type of protocol, but again this is another protocol, what we call the RTSP. This is used basically, and the TCP/IP protocol also supports now this type of called RTSP, real-time streaming protocol, basically used for the real-time delivery of the data. So when we say the TCP/IP protocol, so not only we have only one or two protocols, but there is a set of protocols which are used for different type of purpose. Now the Real Media, we'll talk about little bit brief about all this one. A very popular player, this is called, we are talking about little bit Real Media now, what they have now. Little bit give you some statistics about standing of this product in the market, which is very widely distributed and available for all major OS platforms. All the operating systems are supporting this type of video streaming technology now. Real Networks claim over 70%. So basically, we will not go into detail, but again, it is very much widely used video streaming technology, and also supported by all OS platforms. The QuickTime that already we discussed, it is the version 4 now, and more than 100 million copies distributed have been worldwide now. The major advantage of the QuickTime are its maturity and the large number of codecs available for it. Its features are open plugin features, that is most of the browsers supports now. To allow third-party codecs to be added, MPEG 1 and MPEG 4 are currently available now. So the QuickTime server, they have also designed, because see right now what we are talking about is that you must have a multimedia video streaming server. If you want to support the video streaming technology, you must have a server for it. So the QuickTime also have designed a server for this one, and also this is designed around the Mac operating system, because you know that it is coming from the Apple. They have own operating system called Mac OS. Like Microsoft is coming with own set of operating system, Windows 95, but the Apple has its own set of operating system. So this server is designed around the Mac OS. Now finally we look about the Windows Media Player now. So all these three vendors have already designed the video streaming server. Now let's look at this one now. The version 8 is now from Microsoft. It is the newcomer to the streaming world. It joined a little bit later than the Apple and the other one. Microsoft gives the player away free, and company marketing might means that format is quickly gaining popularity. This is just coming up, and already they are claiming that more than 220 million people are using and different languages. So this is another very popular product now. They are also coming with the server, Microsoft streaming server. They call it Microsoft Media Service. Let me correct now. Again, it is free, and the software is free and supplied as standard under Windows 2000. So if you are purchasing Windows 2000 operating system, The streaming server is a part of it. And again, also you can download freely from the Windows Microsoft sites now. Microsoft not open source the code, but again it's not open means you cannot, it's not like Unix type of operating system. The source code is not freely available. This is considered a major disadvantage as far as flexibility is concerned. That is again the policy of the Microsoft, that none of their products are follow the open standard. I mean, source code is not available, just like Unix or another type of product, Linux and so on. Now with all this, so basically what we have explained to you so far is that what is video streaming, what are the basic problems. So what we came to the conclusion that the video streaming has many problems, and one of the most important problems with the video streaming is that what we call them bandwidth problem. That is the general problem with the multimedia delivery on the world. The second problem, which is related to the multimedia delivery over the World Wide Web, not exactly video streaming, is the synchronization. Like for example, if I am speaking something, my text should synchronize my audio, or the audio should synchronize with the video and so on. So that synchronization has to be again supported by all these things now. And again, the real problem with the video streaming, there is something already discussed, is the internet is the basic problem, because internet is not meant for delivery of multimedia on in the real time basis. They are designed for different purpose. That is why even TCP/IP protocol was not designed for that purpose now. Here the time is more important than the accuracy of the data. So again, and lots of research is going on, and lots of vendors have already come with different type of technology to support the multimedia. So I am referring to that there is we are coming with TCP/IP version 6, which supports lots of multimedia component. Now the question is, why use? Of course I have answered this question, but let me just to conceptualize the point why we use a streaming video. Still, if you have not understood now, a streaming video can be used for live or recorded events. Now if live discussion, the main reason for broadcasting live is to reach a wider or more dispersed audience. Now typical live broadcast could be the lectures, sports, entertainment events, or any academic or any other ceremony. So we are talking about that type of events where you can use a streaming video. Now why live video is essential? Because if the basic idea is that you give them same feeling that someone is talking to you in the class, or I am talking about in academically. So that is the feeling that you are not in basically the, like for example here we are having discussions, live discussion is going on, so you can ask question, I can give you that feeling must be there in the academics when you are doing some advanced course type of thing. Now the stream broadcast should be considered to be so this is basically what we are talking about. The most important component if the multimedia streaming is the full motion video. That is something has to be there. But most important point what we are talking about is streaming video is that you have to bring certain live type of event, and if you have visualized those type of situations, you can use the video streaming type of technology. Now again, although we have given you some idea, but again little bit I will just, one of the most important component in the video streaming is what we call them a streaming server now. So you know what is a server, right? For everything you require, for example, you must have, when I am just like suppose that if you are part of the internet, then and if you are supporting the FTP, then you must have a FTP server built into it, or you must have a telnet server must be built into it. So similarly, the streaming server is there. Just as a web server delivered. Now what is a streaming server? What is the basic functionality of a streaming server? Just as a web server delivers pages to the web browser over the internet, the streaming server delivers media clips to the client. This is basically, so basic idea of a streaming server is to deliver the multimedia in terms of clips or frames. Clips are, again the various tools are there to create those clips. Now real time streaming requires a specific server, that is basically, so server is entirely different kind you must have than the normal type of requirement. Real networks, Microsoft, Apple all provide a streaming server. These servers give you a greater level of control over your media delivery, but can be more complicated to set up at an administrator than a standard HTTP server. You know that if you are part of the internet, then your machine must have HTTP server. That is what is HTTP? HTTP is a basic protocol which is used for the browsing purpose. In internet model, what we call the OSI model, you have number of layers, and for each layer there is a number of protocols now. So HTTP, FTP, Telnet, all are what we call them applications layer protocols. But right now what we are talking about, that if you are part of the internet, you have a unique IP address, then your machine must have a TCP/IP server or the HTTP server. Similarly, if you want to support the multimedia delivery or supporting streaming video, you must have a what we call them streaming server at your end. Now, what are the problems now? The problems already listed, but let me conceptualize once again now. The bandwidth over the internet, that is increasing rapidly now. But unfortunately, demand seems to be keeping with supply. There is still real problem is of bandwidth. More bandwidth you are adding, more demands is increasing also. So increasing bandwidth alone is not likely to solve all the problems. In fact, various developments are taking place now. This is the problem. What is the problem? Problem is of bandwidth. But what we discussed now, that by simply increasing the bandwidth, you will not solve all the problem. What are the problems? Then how will you solve this problem? The various developments are taking place which should ultimately result in quality of service now. We have some discussions in the ATM in context of CSI 13 or CSI 09, and we explained that what is the quality of service. If you just look at the transport layer protocol or transport layer functionality, we discuss what is the quality of service in the transport layer mechanism. Basic job of transport layer is to provide quality of service over the IP now. That if, for example, let me just give you what exactly, and then again let me first finish this one, then we will explain with the terms now. So this is the quality of service has to be addressed, being available over IP. So this is problem being addressed now, and together with convergence of CDNs, we will talk about CDN little bit later on, should result in a rapid growth in the use of video over the internet. So what we are talking about, that the quality of service should be addressed with the TCP/IP protocol apart from increasing the internet, and that way we will try to solve the problem of the video streaming now. What are the models of the streaming models now? The components of the streaming model or video streaming model is that you must have the client or the player and the server and some sort of content creations process. So three components are there in the video streaming model. One is the server, we already discussed. The content, you are playing that the media, and the second is how to create a multi video streaming content. So the third component in this model is content creations process. As always, content is the king, so that is something you have to focus very much if you want to support the video streaming now. Now what we have now, let me just little bit talk about what is the content creations now in terms of the video streaming now. There are large number of tools are available to produce the contents now. So these tools, what they do now, let's look at this one. These tools which we have for what we call them content creations tools, they convert audio, video or animations to a data type format. So basically tools are meant for conversion of all the audio, video or animations to a data type format that the server can stream now. So this is basically because most server can deliver content in many different formats, but they have to be in the protocol which the internet understands. There are a number of tools that people can use them in creating contents. There are large number of tools are there. So productions tool can optimize the contents for efficient delivery over the net. So basic issues which are required here to understand how they can optimize according to the way the internet can deliver them in optimal fashion. So this is basically called content creations now. So we are talking about number of tools which can convert them from audio, video, animations, graphics into the format which internet can understand and deliver them. So this is called the so these three, so each of these three which we have listed earlier, like MPEG, what we call them, Microsoft or the Apple, they have a large number of tools already they have created now. Let's talk about what that they are basically. Each of the big three servers provide tools for creating and converting content into a format that can be handled by their servers and optimized for internet streaming. Like for example, a real network, a real producer 8 will convert from a number of raw formats, AVI, MPEG-1, AU. So because this is a sound format, AU is a sound format, MIDI is another format now. So they convert into a format which internet can deliver. So basically what we are talking about, that large number of tools are available, they convert them, your audio format, your video format into the format which internet can deliver them. Some of the vocabulary you have to understand. Just briefly I will summarize and take up your questions now. Some of the strong, I mean the basics things which you have to understand in creating the important vocabulary which comes across into the video streaming. One called ASF file. The first is ASF file. It is a video file itself. Some of the standards are there. These are the vocabulary people ask sometimes. What is ASF file? It is a video file itself. ASF is the extension of Microsoft uses now. If you are using the Microsoft tool for creating the content for a for video streaming, then the file is called ASF file, which the server creates now, and basically it contains the video file basically. ASX file is another file which they use now. It's a text file that contains the location of the AS file, where it is located now. The video streaming page HTML points to this file and not the SSF file. So these are the few things which you have to understand. The another one is the broadcast, that you understand. In fact, we have started explaining what is the video streaming by explaining what is the broadcast now. Now what is the broadcast, that you all understand. But let me just to send the stream means audio, video, anything, to a broadcast server where it is available for outside people to view. Because it is broadcast from a specific delivery point, it is similar to delivery to array. So basically what we are talking about, that video streaming is just like a broadcast. It is important if your class is broadcast live and something like this. So basically the another important component is what is a broadcast, that you have to understand, because video streaming is also a broadcast, but only the difference is that it is not a analog type. It's basically what we call digital format we are using now, and also the internet is the delivery model for broadcast. The again CDN, the term which we have called content delivery network. This is another important concept which you have to understand. A network of server which with a distributed content placed at major backbones of the internet, because here we are talking about the video streaming server. It's a very heavy document you have to put now. So that basically there might be number of other servers might be attached together to provide you the content. So what we are talking about, content delivery network is a set of servers which is used to support the contents for the delivery through the net. There is high stream, there is a word is called high stream, there is a low stream, there is a high stream, and the video stream, that is the basic rate which has been fixed now. The video stream that is encoded at 100 kbps, this is supposed to be what we call them high stream. There is a low stream now, the video stream that is encoded at 37 kbps and so on, that is what we call them, this is called low streams and so on. So this is all we have about the video streaming. Let me just quickly summarize now what we have discussed now. This is an emerging topic and related to multimedia and the internet. More important precisely, that the video streaming is a technology to deliver the multimedia, live multimedia through World Wide Web. So we discuss what is the video streaming models, what are the problems which we come across when we deliver the multimedia through the net, because the internet was not basically designed for delivering the data in the real time or the multimedia in the internet. Original version of HTML didn't contain anything, but now lots of trends, lots of research is going on to support the multimedia through the net. One basic problem is that again the protocol does not support, but the most important problem is the bandwidth. Bandwidth is very much important. But what we discussed later on, that bandwidth is not only the issue, because if you increase more bandwidth will be required by the software or the multimedia. So what is more important is the quality of service is required now. Like for example, that the packet loss is very less. That is called quality of service now. So and because TCP/IP protocol didn't handle all these things, TCP/IP protocol is not designed for transmitting of the data. But today lots of research is going on, so the TCP/IP can also transmit data in the real time. Now we have some questions to. I think some students are sitting, so we'll take up few questions related to this one. Yes, please.
What is the basic feature of MPEG-4?
These are the standards. No, these are the basically they are called compression standards now. MPEG-1, MPEG-4, MPEG-7, MPEG-21, MPEG-9. They all are compression standards now. See, right now you try to understand one thing is that the if the file is very large, and if you are using internet for delivery model, then it will take lots of time. So you have to compress them so that the file could be smaller, and then you can transmit your data faster. For example, if I have to transmit the stereo file, then it takes double the size of the mono file. So one way to reduce the size of the audio file, that you move from stereo to mono, you just reducing the file size by half. So all these more details you have to look at the literature, but right now the basic idea is that the compression should be higher, so that file size should be smaller, so that time delivery could be smaller. So one can say that.
Sir, how to multimedia support the object-oriented user interface?
See, basically, just repeat one's questions now.
How to multimedia?
Support
the object-oriented user interface?
See, right now, I think let me, if you understand, I will just coin the questions in different forms. See, today the object-oriented technology. Let's try to understand like this. Object-oriented technology is the basic technology for designing all the multimedia documents now. You know that I will give you an example of a Java programming language. For example, Java is a fully object-oriented programming language. Now Java has a full support of the multimedia. You can create animations, you can create a audio file, you can create a video file, you can create a image, graphics, everything. So basically today the object-oriented technology has become the basic for designing the all the multimedia document. No, not only in the multimedia, even otherwise in all these basics, any software development, the object-oriented is the basic technology for designing the multimedia. Yes, please.
So, what is basic requirements of network to multimedia delivery?
So I think the basic issues for supporting multimedia through the net is the bandwidth. You require very high bandwidth, right? Because this file size is very high. Number one. Number two is that it has to be played in real time. Now the point is that unless you have a high bandwidth, so basically bandwidth is more important, number one. Number two is the quality of the bandwidth. That is another important. Now, for example, even if you have a 2 Mbps lease line service, and I have given various instances that we had sometimes 2 Mbps lease line, but we didn't get 2 Mbps. So what we are talking about, bandwidth is one, and the second one is the quality of the bandwidth which is being supported by your ISPs has to be very important. Two things are very much important.
What is support for multimedia in Java programming language?
Java has many packages now. Java has many packages. If you look at the java.awt, there is another important package now. So Java supports many library packages. They gives you the you can design over multimedia, like java.awt gives you lots of things, graphics, images. You can create a sound, you can create animations. So that thing you can have in Java. So you have lots of packages for creating animations, graphics, sound, and so on. So these are the few features you have in Java programming language. Even Java has lots of features otherwise for doing the network programming, I will say you. Like for example, today you have the you can do own TCP/IP programming in Java programming language. For example, you can simulate the whole HTTP protocol, FTP protocol, Telnet protocol. You can write your own protocol. Earlier, for writing the TCP/IP, you had to write the code into the C programming language that was quite lengthy and tedious. Today, one can write this type of program, any client-server type of program in Java, much more faster and much more easier than what you people used to do in the in C language under Unix operating system. So Java has a lots of features. In fact, you can explore them. You can create your own multimedia versions in Java as a part of your, like for example, if you are doing something in CSI 27, that is something very closer to the multimedia, you can do as a part of your project. In fact, 5th trimester, you are doing lots of projects, so you can pick up some of the projects, do some multimedia things, like you can have a multimedia presentations for various things using Java programming language itself.
What is MPEG and what its role in video streaming?
So the MPEG, they are the open standards, that you have. See, what you require is they are the compression standards now. You know that for the questions raised earlier, that if you want to send for multimedia transmissions, live multimedia transmissions, you require, the file is quite heavy now. So the file has to be compressed now. So MPEG is just open standard which has different version, MPEG 1, MPEG 4, MPEG 7, MPEG 21, lots of things are coming now. So they are basically used for defining compression standards for the multimedia transmissions, or even multimedia as such, because to store the multimedia itself you require some compression standard, and forget about the transmissions part. So they are basically the open standards. They are open standards. They are used for the compressing the file. And again, different ratios are there. In fact, you as a part of your study, you can take various type of technology and can see where is the compression, what is for what are the standards. Some are used for the graphics, some used for the images, some are used for the videos, and so on. So that is the whole.
What is VHS quality video service?
So the VHS quality is something what we see the normal. You have seen the normal the Gyan Darshan presentations. Even some of the, these are called the, you have look at some of the your video presentations on this topic. But some of the Gyan, the quality which we are using them here for the transmission is very similar to the VHS quality.
What is the difference between a streaming server and another server?
The streaming, the another server, if see, we give you two examples now. The two examples we are going to give you that HTTP server, for example. Like for example, if you want to become a part of the internet, your machine must have a HTTP server, right? Because HTTP is basic protocol for browsing the net. Right, so these are basically deal with the actual normal type of textual or the textual type of informations now. But video streaming server is entirely different, because they are dealing with lots of heavy files, because it is a multimedia file, audio, video, this one. So the delivery, the servicing, the request for the multimedia document that also in the real time has to be very, very fast. The technology has to be very, very fast, because the response time has to be very, very fast. That is the difference between the two. So what they do is that most of the servers which they have is they contain number of what we call them CDN, content development network. They have a number of servers which to support the content delivery now. So basically just like this server, but they deal with more multimedia type of documents. So basically we do, that we deal with two types of data, what we call them the normal data which we use them, and then we have the multimedia data. Multimedia data is entirely different, so the delivery has to be treated entirely different way as we deliver the normal textual data. Yes, please.
So what is the basic difference between video streaming and broadcasting?
The normal broadcasting, the normal broadcasting is just like a radio broadcast, television broadcast. This is normal broadcast now. Video streaming is also a broadcast, but here what we are talking about, the broadcasting through the World Wide Web. Right? The problem which we come across with the video streaming, we don't come across with the normal audio, normal radio broadcast and the television broadcast. Here the bandwidth is a basic issues now, and also the quality of the bandwidth. The real problem which we don't face in the normal broadcast is that they were meant for that purpose, whereas the internet was not meant for the not meant for the video streaming or broadcasting in the real time, because the TCP/IP protocol was not meant for that. So that is the basic problems you have. Any other problems you have? Yes. Yes.
What is networking in Java program?
No, there. You see, right now you see what we have in Java is basically designed for exploiting the net. That was the basic idea. Like each programming language has got certain objective, and Java programming language are designed to exploit the net. Java uses internet as a delivery mechanism. Java assumes that the source code or the exe file is going to be delivered through the net, right? So Java supports the feature of a network programming. Java supports the feature for multimedia programming. In fact, Java, you have one package called java.net. Now java.net is a library package where you have lots of classes for defining the for writing the networking program. For example, you can write own client software, you can write own server software. I give you example that through java.net you can write you can simulate HTTP server, right? You can simulate HTTP server, you can simulate your own FTP server. If you want to modify how does HTTP works, you can write your own programs, you can write your own FTP program and so on, and many other type of program one can think of it. So anyway, this is all we had, and again let me brief you about that the website. In fact, I request you all to read the newsletter which we are writing every week. Every Monday we issue the newsletter, and all the latest information about the program we keep on informing you through the newsletter. The same newsletter is also available on the net. You can browse them. We have also redesigned our website, so all the latest information, even day-to-day information we are putting on the net. In fact, the new dimension which we have added to our website is that every week we are giving some new article, and that is emerging article, and which for all of you, please read. Even I request all the students that if they have a good article which they want to contribute, if they want to share with among all the students, but it must be of high quality, they can pass on to me and I can publish those articles on the net. This is all we had. Thank you very much.